This video, we are going to look at inverse trig functions only for the sine, cosine, and tangent. Take a minute to draw a nice parent sine curve. That's the parent sine curve. The domain is all real numbers, so negative infinity to infinity. And the range is -1 to 1 included, and that's an interval notation. Okay. If I asked you to find some angle theta who has a sine of, let's just say 1/2. So I'm telling you that the sine of theta is 1/2. What's theta? Okay, so 1/2, I mean, you hopefully can do this off the top of your head. You should know that it's pi over 6 and 5 pi over 6. But how do you do it graphically? So 1/2 is, I don't know, here somewhere. And you would see, where does the line of y equals 1/2, sine theta equals 1/2, where does that intersect the curve? And we would have in two places, and we would say that theta is pi over 6 and 5 pi over 6. So that's how we would find the answer graphically. Like I said, I think we know that off the top of our head. Okay, if I want to find the inverse of the sine function, well, what do? We switch x and y. So if I'm going to find the inverse, here the domain are my angle measures, and my range are my sine measures. So if I'm going to find the inverse, which is indicated by, that is inverse sine notation, now x, instead of representing theta, x represents the value of the sine. And y represents the value of theta. The angle measure. Okay, well, when you find an inverse, you also switch x and y. So I'm warning you now, you might want to use a pencil because I am going to be doing some erasing. So normally we would say that if the domain of the curve is, the domain of the function is all real numbers, so that means that the range of the inverse should be all real numbers. So switch domain and range, switch x and y. So for the inverse function, the domain is now -1 to 1. And again, I would be using pencil because I am going to erase or white out or whatever. -infinity to infinity. Let's draw a graph. Switch x and y. So my theta axis is now y, and my sine theta axis is now x. Let's take a minute to graph this. Okay, so this is now my theta. I'm sorry, my sine of theta. This is now my sine theta, and y is now my theta axis. Okay, so switch x and y. So go ahead and sketch a graph on your own. Use some ordered pairs from here, switch them, and go ahead and sketch a graph and see what you come up with. And here's what you've got. What is wrong with this curve? What's wrong is not that my curve isn't very pretty. That's not what's wrong. Take a second to figure out what's wrong with this curve. Fails the vertical line test. So if that was the answer that you came up with, you are correct. This fails the vertical line test. The parent fails the horizontal line test, which means its inverse fails the vertical line test. So my range cannot be from -infinity to infinity. Well, what's going on here? For sure, we know that the domain is from -1 to 1. That is okay. The domain's from -1 to 1, but I need to adjust this. Well, I'm going to start at the origin. Parent starts at the origin. Just about everything starts on the either x or the y-axis. So here we go. And I have my curve, and everything's all good to go. And as soon as I get past 1 and I start to curve around towards pi, as soon as I hit this point right here or whatever, bam, I start to fail the vertical line test. So I can't curve around towards pi because the second that I round the corner, so to speak, fail the vertical line test. Oh boy. So this is not okay. I start to curve around, bam, fail. Okay. Well, from 0 to pi over 2, so here's 0, and here is pi over 2, and pi, and 3 pi over 2. This is my first quadrant. So from 0 to pi over 2 on the unit circle, that's the first quadrant. I hit all the possible positive values for sine. From 0 to 1, that's all positive numbers, all the positive possible sine values. How am I going to hit the negative possible sine values? Oh, all right. If I were to continue this curve, which is not right, I'm going to erase it again. This curve does technically go below the sine theta axis. Negative pi over 2. Oh, that's not a very good curve. That's a little bit better. This passes the vertical line test from 0. This is negative pi over 2. Sorry about that. That's negative. From 0 to negative pi over 2, I hit all of the negative values for sine. So on the sine theta axis from 0 to -1, that is all the possible negative values for sine. And that occurs between 0 and negative pi over 2. Well, 0 is 3 pi over 2 the same thing as negative pi over 2? Those are the same. Going around counterclockwise, going clockwise, those are the same value. This is quadrant 4 on the unit circle. From 0 to negative pi over 2 is quadrant 4 on the unit circle, and that covers all of my negative sine values. So I'm going to erase this, but if I were to keep going, right, you have the curve and it goes only the part between negative pi over 2 and positive pi over 2 is in my range. Included. Okay. So that's critical that you understand that the range is only in the fourth quadrant, negative pi over 2 up to positive pi over 2. That gets all your positive sine values, all your negative sine values, and that's in between negative pi over 2 and pi over 2. So I want to go back to this question that I asked you up here. And I said, okay, if the sine of theta is 1/2, there were 2 answers. Horizontal line, 1/2, 2 answers. If I change that around and I say the inverse sine of 1/2, I want to find out what y is. There's only one answer because I'm using the inverse function. So the inverse function, here's 1/2. Use a vertical line this time. It's that point right there. The only answer is pi over 6. If 5 pi over 6 falls outside of the range. It's just pi over 6. The notation matters. So when I'm giving you that the sine of theta is a half, you're solving for theta using the sine curve. When you are given inverse notation and you are given the value of the sine, there's only one answer because you are evaluating the inverse sine curve. Let's do the same thing with the cosine. So draw a sketch of your cosine curve, and we will sketch the inverse cosine. There's your cosine curve. Domain is all real numbers. Range is from -1 to 1 inclusive. So when I do the inverse function, I'm not exactly going to switch the domain and the range. This passes the vertical line test, which means the inverse should pass the horizontal line test. Switch domain and range, so vertical line test becomes horizontal line test. So on your own, let's try and sketch a graph of what you think the inverse cosine curve might look like. That is sort of what the inverse cosine curve looks like. Switch domain and range, kind of, sort of. So what's happening here is, again, it fails the vertical line test. So we need to cut out, so to speak, part of the graph so that it passes. Okay, this is 0 theta. So from 0 to pi over 2, first quadrant, from 0 to pi over 2, all of my positive cosine values are taken care of. This is cosine, and this is theta. From 0 to pi over 2, quadrant 1, all of the positive cosine values are taken care of. From pi over 2 to pi, from pi over 2 to pi, all of my negative cosine values are taken care of. And what happens is, so I'm coming up, as soon as I round the corner at pi -1, or -1 pi, sorry, at -1 pi, as soon as I round that corner, I fail the vertical line test. So guess what? We're going to cut it out. And this is what the inverse cosine curve looks like. So the domain of the inverse cosine is -1 to 1, but the range is from 0 to pi, and that should be included. All right, let's say I ask you to find the where is the cosine theta? How about -√2 over 2? Okay, so figure out where is the cosine of theta -√2 over 2. I'm using, right, I'm not giving you any kind of inverse notation. So I want the regular old cosine curve, -√2 over 2, which is somewhere between 0 and -1, horizontal line, it crosses twice. You really hopefully don't need the graph. Figure out where is the inverse cosine -√2 over 2 in radians. And hopefully you came up with 3 pi over 4 and 5 pi over 4. But now let's do the reverse. If I ask you to find the inverse cosine of -√2 over 2, only one of those answers is correct. -√2 over 2 is between 0 and -1, just like it was in the sine curve. Between 0, -1, -√2 over 2 intersects the curve twice. Here, it only intersects the curve once. So I know the question I'm going to get is, how do you know when there's 2 answers or 1 answer? It depends on how the problem is given to you. This is saying to you, I've got an angle, or I have, the cosine is this measure. What are the angles? Here I'm saying the inverse of the cosine is this measure. What's the angle? So it really matters. It's a notation issue. Solving for theta, here I'm given the cosine and I need to work backwards. Okay. Let's do a sign that tends to mess people up. Sorry, before I do that, knowing the domain and the range is what's critical. Knowing that for cosine, the range is from 0 to pi, and 0 to pi is quadrants 1 and 2. 0 to pi is quadrants 1 and 2. For the sine, the range is negative pi over 2 to pi over 2, which is quadrants 1 and 4. 4 and 1, 1 and 4, whatever. Let's do a sine where it's a little bit funkier with the range. Let's do the inverse sine of negative root 3 over 2. When you are given a positive sine, cosine, tangent, whatever it is, it's always quadrant 1. You have to worry about the negatives. You have to worry about the negatives. So I know that 60 degrees pi over 3 has a sine of root 3 over 2. I hope that's right. Yeah. So let's draw it. Pi over 3, so it's negative root 3 over 2. So negative root 3 over 2 is in quadrants 1 and 4. Okay, so that would be 60 degrees, which is whatever this is, 4 pi over 3 and 5 pi over 3. This is the answer I often get. Oh, okay, so it's got to be in quadrant 4. I understand that if it's a negative sign value, it has to be in quadrant 4. So this would be 5 pi over 3. Great. Quadrant 4, negative sign, 60 degrees, 5 pi over 3, and the answer is no. 5 pi over 3 falls outside of the range. The range for the sine curve is negative pi over 2 to positive pi over 2. 5 pi over 3 does not fall between negative pi over 2 and positive pi over 2. The answer is negative pi over 3. Five pi over 3 falls outside of the range. Where does the range come from? The range comes from here. So if you look, negative or positive 5 pi over 3 is up here somewhere. That's not even on my graph. Negative root 3 over 2 is between 0 and negative 1. Whatever, let's just say it's here. Intersects the graph right there, negative pi over 3. Take a quick look at tangents. It's important that you don't have to know how to shift any of them, but it is important that you know the parent function. So go ahead and graph the parent tangent. There is your parent. Remember that tangent is sine over cosine. So where the cosine is 0, if the cosine is 0, the function is undefined, and undefined presents itself as a vertical asymptote on the graph. The domain is not included. Negative pi over 2 to pi over 2. This is the domain of the parent. The domain of the overall function is pi over 2 plus odd integer multiples. Say that 10 times fast. Pi over 2 with odd integer multiples. Odd integer multiples because 1 pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. So they are odd integer multiples. So when I do my inverse tangent, this one is actually not nearly as awkward to graph, I don't think. So let's go ahead and graph it with you. Hopefully, we're just going to switch the domain and the range. And in this case, we will. Because the parent passes vertical and horizontal line test. So the inverse will therefore automatically be a function. So let's just say we've got pi over 2, negative pi over 2. We've got some asymptotes going on. And then we're going to draw our function, and I'm actually going to cheat. Draw it this way. And this is the inverse function. Oops. And we do indeed switch the domain and range. So from 0 to pi over 2, the tangent values are positive. From 0 to pi over 2, the tangent values are positive. So we are going to indeed switch the domain and the range. So the domain is negative infinity to infinity, and the range is negative pi over 2 to positive pi over 2, plus odd integer multiples, blah, blah. And that is a shape of the inverse tangent. Let's just do a quick summary of all three of the functions. Inverse sine. The domain is from -1 to 1, and the range is negative pi over 2 to positive pi over 2. Cosine. Domain is also -1 to 1, but the range this time is 0 to pi. Included, there's no asymptotes. And the tangent, I just told you, is right there. All right, last thing we're going to look at is actually solving for an inverse function. We're going to solve for an inverse function. Last thing. I can give you that the function is equal to 3 times the sine of 2x. Okay, let's find the domain and range before we do anything else. Let's find the domain and the range of this function. The domain, omega is 2, so the period is pi. And the range, the amplitude is 3, so the range is from -3 to 3. If you need to, draw a quick little sketch for yourself. Amplitude is 3, so there's your range. Omega, the coefficient on the variable, is 2, so 2 pi over 2 to find the period is pi. 0 to pi. Sometimes it helps to maybe just draw a quick sketch for yourself. I want to find the inverse. I want to find the inverse. Okay, well, first thing we should do is switch x and y. So we're going to get x equals 3 times the sine of 2y. Divide both sides by 3. So we get 1/3 x, or x over 3, whatever. Okay. This is a little bit funky. I can't divide both sides by 2. That's voodoo math. So I'm going to find the inverse. So the angle measure is going to become the sine, and the sine is going to become the angle measure. So this is going to be rewritten as 2y equals the inverse sine of, I'm just going to write it as x over 3. It's a little bit cleaner. Okay, so here's what I did. I can't solve for y. It's kind of like when you have an exponential form and log form. If it's an exponential form, we switch it to log form and vice versa. Well, that's exactly what we're doing here. Only way to solve for the angle measure is to use an inverse sign. And this now becomes y equals 1/2 the inverse sine of x over 3. And that is the inverse. So I'm okay with my domain. Switch the domain and range, and so the domain of the inverse function is just going to be from -3 to 3. That's not where my worries come in. My worries come in with what is my new range. So I am going to sketch a little bit more of a specific graph than the one I just sketched at the beginning. So let's draw a little bit more of a graph with some more intervals. This would have intervals of pi over 4. That's why it's so important that you know those. Pi over 2, 3 pi over 4, and pi. So the domain of this inverse that we just found is going to be -3 to 3. That's no problem. The issue becomes, what is my new range? Well, if you were to sketch this, which I will do right now, and let's hope I don't mess it up. So I have my -3 to 3, and then my intervals are pi over 4, pi over 2, and then how about negative pi over 4? It's pretty hard to read, sorry. These are all in fourths. Negative pi over 4, pi over 4, pi over 2. Well, when you sketch this, and you have that it goes through 0, 0, and it goes through 3 pi over 4, and then as soon as I turn this corner, I can't. As soon as I turn the corner here, or round the corner, I should say, boom, fails the vertical line test. So my range for this inverse function is from negative pi over 4 to pi over 4. Will it always be, like when you divide the intervals in 4, so it's, positive pi over 4, will it always be the symmetric opposite at negative pi over 4? And the answer is yes. So if this was pi over 6, then I would have negative pi over 6, and my range would be negative pi over 6 to positive pi over 6. If this was 17 pi over 3, then I would have negative 17 pi over 3, and my range would be negative 17 pi over 3 to positive 17 pi over 3. So that's why it's super important that you know how to divide your intervals into fourths. So that is the range of this inverse function.